My name is Tyler Bui-Palsulich. I'm a developer programs engineer at Google, and I work on Go and Google Cloud Platform. My goal is essentially to make it as enjoyable and easy to use Go with and on Google Cloud as possible. So with that said, today I'm going to be talking about running and maintaining Go serverless applications. And I specifically put running and maintaining in the title here because getting something running and started is only part of the process. You make it available once, you need to keep it available and fast and usable for your users. So with that said, I think kind of the best way to do this is with a demo. So what I'm going to be doing today is building a web application. It's very, very complicated. You may have heard of it before, maybe. Let me know. It's called Hello World. All right, a couple people. And I'm going to be starting from scratch today, and I'm using Cloud Shell here. So Cloud Shell is a service from Google Cloud where we spin up a virtual machine and then give you a terminal. So if you go to console.cloud.google.com/cloudshell, you come here. As long as you have an account, you get to this page. So anything I'm showing today, you can hopefully do yourself. And the first step will be setting a project. So config set project. And I created one for this talk called Serverless Gopher, because that's what we all are. And I'm going to create a new directory called hello, cd into that. I really did create it. It didn't exist before, nothing in here. And the first step in any Go project is creating a new Go module. So how many people have heard of modules before? Awesome, tons of people. All right, so to create a module, you're going to use go mod init example.com/, I'm going to call this hello. And this creates one file. It's called go.mod in this directory. And right now, this is really simple. It has two main lines. One is module example.com/hello. This gives us the name of this module. All of the Go packages that we create inside of this module will be prefixed by this module name. And then the other line says Go 1.12. So you can see here I'm using Go 1.12. It's the default for Cloud Shell. And what this 1.12 line in the module file is saying is this module was built with 1.12. That's the intention. So if you're on something older, say 1.11, optimistically try to compile with this. If it works, awesome. If it doesn't, well, because you need 1.12. So it's kind of this forward-looking idea of hopefully in the future, as we add more things to Go, we can support modules back and forth. With that said, let's actually write some Go code. So I'm going to start by creating a web handler. And I'm just going to do this with the standard library net HTTP package. Package hello. We're going to have one function called hello, and it will always respond with hello world. And this is following the handler func, or that's our goal for this. So we need two arguments for this function. One is a response writer from the HTTP package, and the other is a request. No return arguments. And then for every request, we're just going to respond with fprintf, respond with hello world. And that's it. And straight off the bat here, save, get imports, cool. Straight off the bat here, this is an HTTP cloud function in Go. Cloud functions for Go are just HTTP handler funcs. From the standard library, all of the usual middleware, if you have logging to say dump debug information about all of your requests or your responses, should just work out of the box. So let's take a look at actually deploying this. So to do that, I'll clear. We're going to use the gcloud command line tool. So gcloud functions deploy. And I'm going to give the name of the cloud function that I want to deploy. And you can also specify an entry point argument. The default for this argument is the name of the Cloud function that you are deploying. In this case, I can just leave it off, and then it defaults to hello, which is the function we just wrote. And then we need two other arguments. One is the runtime. So I'm going to use Go 111. And for Cloud functions, Go 111 just went generally available at Next a couple days ago. And then 1.12 is available in alpha. So if you're interested in that, find me after the show, and I can get you signed up. The other argument we need is what trigger type do we need for this Cloud function. And in this case, I'm going to use HTTP. And HTTP means this code is going to be deployed. We're copying up, or the gcloud tool will copy up all of the current directory, which means our current module, send that up to Google servers. It'll build that code, make sure it's working, and then make that endpoint URL available, ideally. And so in this case, I'm using HTTP, but there's one other type of Cloud function that you can write. Those are background functions. And background functions respond to events that happen. And in a way, you can think of visiting some HTTP URL as an event that happens, but what I mean in this case is something like pub/sub. So pub/sub is this distributed message bus where you can send messages into it on a topic that you define, and then subscribe to it other places. And if you're running on, say, Compute Engine or App Engine or somewhere else, you might subscribe manually to that topic. With Cloud functions, you don't have to do that. You just say, attach this Cloud function to this pub/sub topic. Every message that gets published here, trigger this Cloud function. So that's really nice. In this case, we have an HTTPS function. You can visit it, click that link, and you get hello world. Awesome. And so you can also do things like cloud storage, where let's say a user uploads a profile picture, and you need to process that picture to, say, make a thumbnail that you can display on your application. That's the perfect use case for Cloud functions, because you send that into a cloud storage bucket, your function gets triggered, process, do whatever image manipulation you need to do, and store it somewhere else. But that doesn't always make the most sense for your entire application. You might have something that's, say, directly user-facing. Maybe it has multiple endpoints that are all working together, and the user travels between them. In that case, it might make more sense to use something like App Engine. And with App Engine, you get an entire HTTP binary that you can be running. So again, let's kind of take a look at what that looks like. So we have our go.mod file, our hello.go file, and we're going to create one more directory called cmd. And in cmd, we are going to create a main package, main.go. And this is a really common pattern in writing Go applications, where you create whatever top-level libraries and packages that you might need to use, and then have a subdirectory for each binary that you would have. So you might have a backend binary, a front-end binary, and so on. And those would be in command backend, command frontend, and so on. In this case, I'm just going to write one web server, so I'm doing just in the command directory. So in here, we have package main. I'm going to write a func main. And this has a few steps. One, we're going to check what port should we be listening on. So the App Engine runtime will set the port environment variable to the port that you should be listening on for your HTTP server. Other than that, whatever setup you need to do can all be dependent on your application, however you prefer to write it. But it is helpful to have a default port in case that environment variable is not set. So for this, I'll do 8080. And then we need to register our handler. So we'll do http.handlefunc. Listen on our port. Use the default or the handler that we just wrote, which is in the hello package, and it was named hello. If everything is working with modules and Go imports, when I save this file, it should just show up as one of the imports. That's what I was saying before, of all of the packages that we create are just prefixed by that module path. We'll see that in a sec. Let's log a message that says where we're listening to. So listening on localhost, and then some port, do a new line. And finally, we can start our server. And I'm wrapping this in a log.fatal call so that when our server ends, if there is some error that triggered the end of that server, we should print that to the console and not just forget about it. So we do that with HTTP listen and serve. So we need our port, whoops, up here. We don't want to listen on a port. We want to listen on some endpoint, which is, we'll say /hello. Here we're listening on some port, default mux, close fatal. And there we go. So at the top here, we have a few imports from standard library, and we have this example.com/hello. And that's really it. And this is how you would write an HTTP server with a standard library. Maybe you have some extra routing logic and things like that, but this is just how you write HTTP servers in Go. And in my opinion, it's super convenient because this is an App Engine server. You can deploy this almost directly. Before we do that, it's helpful, before you try to deploy something on a cloud service, you might want to run it locally. And in this case, if it's a Hello World web server, how can we do that? Well, call go build. Let's output this to the current directory as a binary named hello. And the binary is in the command subdirectory. So that's going to build a hello binary. So we get this log message listening on localhost 8080. And I know what you're thinking. You're like, Tyler, you're in Cloud Shell right now. That's in some data center, probably in Kansas or something. Where's localhost? So there's a convenient, I found out about this as I was prepping this, but there's this web preview up here, and you can specify a port. And then you get some endpoint here. And this is pretending like localhost for you, proxied through Cloud Shell. And if you get its HTTPS up here, the authentication is required. So if you open an incognito window, it says sign in. So only you as the developer, it's just secure by default, can access this. Really nice, helpful for prototyping. If you're on a Chromebook or working in Cloud Shell in general, really helpful. All right, so we can close those, stop our server. And to deploy on App Engine, we need one more file called an app.yaml. And we're going to do App Engine standard here. I'll talk about flexible in a second. But we need a couple lines. One is the runtime. Again, we're going to use Go 111. For App Engine, there's Go 111, and Go 112 just went to beta. So if you want to use that, you can. In this case, I'll stick with 111 as GA. And then we need another line that says, what is the main package? What is the binary that we are going to be running? In that case, or in this case, it's in the command subdirectory. And this is helpful for modules, because as you're developing your application, your binary might be a few directories deep, and that's super common and super helpful and a nice way to design your application. But for App Engine, you need to deploy that entire module so you can import everything that's needed. Like we have our binary importing the hello, so we need this entire module directory. So we say the main command is cmd, save, and then we can run gcloud app deploy. And this is going to go through the same kind of build process that we went through for Cloud Functions, where the current code gets zipped up, sent to cloud storage. You can see uploading 3 files to cloud storage. It builds on Google servers, makes sure that the application works, and then deploys it at your endpoint. So you might have some custom domain, or you can see this is going to go at serverlessgopher.appspot.com. And so this is using App Engine Standard, and specifically App Engine Standard second generation. And that's built on top of gvisor, which gives like sandbox security to your application. So that means any package that you want to use, you can. In first generation runtimes on App Engine, you had to use specific packages to do things like HTTP requests. So you would go to use just standard like HTTP default client get, and then you would get some runtime failure when you deployed your application saying you can't do that. Same thing with contexts. Now you can use whatever context you want. You can just grab the request context directly, and you don't have to worry about it. App Engine Flexible is similar to App Engine Standard, except you get to, one, it has a minimum instance count of 1. So with Standard, you can go down to 0. Flex, you have to have a minimum of 1. That means you're being charged as it runs. If no one's using it, you're still paying money for it. Not very nice to use. A nice thing is that you get container images. But I'll talk about container images after I show you this. So let's take this URL. We just deployed it. Copy. We defined the /hello endpoint, and we get hello world. Awesome. And I'll call out here, we didn't make any changes to the cloud function that we deployed. And that's kind of the point. The code that you're writing shouldn't be dependent on where you're deploying it. Kind of the Go code in one place is the Go code in another. But sometimes you need one more level of granularity higher than, say, App Engine or just the binary. And so that might be because you need additional tools that are right next to your server that your server might, say, shell out to. Or you define some native code that depends on the type of machine that's running it. And in those cases, you can use a container. And containers can be deployed in a serverless way, same kind of scaling up and down as you need with Cloud Run. So Cloud Run, announced again a couple days ago, does serverless containers. So you say, I'm going to deploy this container, or I'm pushing it and I'm storing it on Google Container Registry, and then deploy that, and it scales as needed. So let's take a look at what that looks like. We're going to need to define our container in some way. And a super common way to do that, or most common, is with a Dockerfile. So I have one already written. Ignore the fact that says buggy. I'll get to that in a sec. And let's take a look at this Dockerfile. So we start on line 1 here, and we say from Golang as builder. This is the kind of root image that we're going to be building our container image in. Say work in the /home directory, and I'll call out for Go applications, this line 5 and 6 is really nice. This says copy in the go.mod and go.sum files, and then run go-mod download. And that's helpful because these are run in different Docker stages, and they get cached as needed. So if your go.mod and your go.sum files don't change, then you don't have to rerun go-mod download. That's really nice when you're developing, because you aren't changing your dependencies every time you save and test or deploy. So you shouldn't have to download all of those dependencies every single time you try to build your container. So that means it might take a couple minutes the first time because you have to download everything, right? And then you make some modification to your code, and then it's just basically the compile time plus whatever it takes for Docker to start. Really nice. I recommend it. Regardless of where you're building and running your code, do this if you're running some container. Line 7 says copy the rest of it in. We compile our binary. And then this is done as a multi-stage build, where the second stage is done from Alpine. And Alpine is a trimmed down, smaller base image that doesn't have extra things that aren't really needed to run a static binary, which you get with Go. But one thing we do need is certificates. And certificates are useful for basically, if you're doing anything with SSL or HTTPS, you'll want to include this line. Finally, we copy our binary, make sure it's executable, set that port environment variable that I defined or talked about earlier. And then the command to start it is /hello. So I deployed this already on Google Container Registry. And you can see that at gcr.io/serverless gopher. And this is the project that I created. And you can see I have one image in here. It's called Hello World. And there are two versions of this. One is 1.0.0, and the other is 1.0.0 buggy. So like I said, I'll get back to buggy in a second, but for right now, I'm going to deploy the 1.0 version. And to do that, we are going to use gcloud again. So gcloud beta, run deploy, and then the one argument we need is image. And this is going to be exactly what that image I just showed you was. So gcr.io/serverless gopher / no period, hello world, and then you can also specify your version. The default version is latest. In this case, I'm going to do 1.0.0, which we just talked about. So we hit deploy here, and this time we aren't copying the source from the current directory. It's just going to download that image from the container registry. I specified US Central. Service name, it defaults to the image name. And we get this deploying container image. We get one option here, allow unauthenticated invocations to service. Yes. That basically means we don't need to log in to hit this, and it's just a little bit more convenient, at least for this demo. And so here, it creates a new service, pulls down that image, starts it up, performs a health check, reroutes traffic to your new version as needed, and as you can see, it literally took a few seconds. Let's open this URL just to make sure it works. We're at /hello, and we get hello world. Very cool. And so kind of from so far, we started with HTTP functions. You might have many of these for your application. They might do many different things. You might have some background functions that are part of your app. But either way, you start with these HTTP handlers. Maybe you say, I need a little bit more control. I want to bundle all of this up together. I want to not have these independently scalable, small, stateless bits of code called cloud functions. I'm going to deploy this as a single binary HTTP server that's running. And then if that's not quite enough, or you need, like I said, those native binaries or those extra tools right next to it, you might add a container image around that and deploy that on Cloud Run. So for Go specific, I've found it really helpful to have these containers to build kind of a Go fumped as a service with a coworker. So that you could just bundle in those Go tools that you needed in your container. When you're running on App Engine, is Go installed? I don't know. If you run in a container, I do know, because you say in that Dockerfile, yes, I need Go, or I need ImageMagick. ImageMagick is included in App Engine, but you get the point. So that's where I've really liked using it. But kind of looking at the big picture here, running it isn't the end of the story. The point of running something is to do something awesome with it. And you might have all of these other things around it, like you're using ML, like Cloud Vision, or building some chatbot, and so on. And the point is not just to have that code running on App Engine, it's to do something cool with it. And regardless, you kind of have to maintain that and keep it going. So now that we have something running, let's talk and shift gears into talking about maintaining that and keeping it going. And the first line of defense that I really see is testing. So it's not really a fun topic. It's kind of a boring topic maybe sometimes. But what I want to call out here is that testing for deploying on GCF or App Engine or Cloud Run is just testing. You aren't running something special that says, because I am running on Cloud Functions, I need this extra stuff. It should just be a normal Go test. If you've ever written Go code, if you've written Go tests before, this is what they look like. In this case, this is using the HTTP test package from the standard library and checks the response code as status OK. If you do have kind of multiple things going on and you want to test that all together, you have production, I recommend creating test projects as needed. And your test project can be completely independent of all of your production resources, and then you don't have to worry about running out or accidentally deleting something from production if it's just a completely separate Google Cloud project. The other thing to keep in mind, and this is kind of true for any microservice application that you're building, is implicit dependencies. So I built one application where users could go to a website and request translations of certain text. So you get free-form input for what text, and then a selector box for what language should that text be translated to. And so that request, that form post response, gets sent to some server. And then I didn't want to run that translation right there, right then, because it might take a little bit long. It might take 100 milliseconds. It might take more. So what I did was I published all of those to PubSub. And I said, here on this topic, go translate this text into French. And then I created a cloud function that listened on that PubSub topic, brought things in, said, OK, I'm going to take that text, translate to French, store it in the database, and then the user refreshes, and they get the list of translations from that database. That's awesome. But you kind of have this implicit dependency there. You have one code that's pushing into PubSub, and this other code that's pulling down from PubSub. And they have that implicit dependency that says, what is the format of that data that's going back and forth? If you're calling it directly, you're writing Go, it just type checks, it compiles, you're good. But if you're going through PubSub, if you're publishing events and so on, you have to be a lot more careful. So I don't have a hard and fast rule that says what's the best way to manage this, but documenting it, having a good, clear picture of where all of the data of your application is going will be super helpful. And the other issue is visibility. So it's like, yeah, sure, Tyler, you're running all these containers. They go up and down. You have, whatever, 25 containers here. What's inside these containers? 30. It's OK. What's inside these containers? Anyone? I don't know. So you need that extra visibility to say, what's inside these? How are they communicating back and forth? Is it fast? Can I debug it? And the way to do that, or at least one way, is with tracing. So tracing, there's a package or a library called OpenCensus. And this is instrumented in multiple languages. In this case, I'm showing Go. But the same principles apply. You start by creating spans, and then you end those spans at some point in the future. In this case, I'm creating a span called example.com/hello.hello. And the convention for creating these is you take your package name dot the function name. That way, later, if you ever need to debug and find the code that's creating this span, you know exactly where to go. And then this calls defer span.end. And defer means this end call will run when the function returns, or at the end of the function. And then what you get from this is it returns a context, and as you pass that context around through your application, you get to see these other spans that are created. And as you create a new span from this context, it all gets attributed to the parent or top-level span that created this. So we'll see an example of what this looks like in a little bit. Once you do that, you have to export that data somewhere. So like I said, OpenCensus is open source, multiple languages. One benefit of that is that the exporter can be whatever you want it to be. So that might be Stackdriver, which I have an example of here. Stackdriver is Google Cloud's application performance monitoring suite. But it might be Datadog, or it might be some local, just print it to standard out as I'm developing. And that makes it really easy to recommend tracing throughout your entire code, because if you ever want to change where you're exporting that data later, it doesn't matter. It's a small, maybe 10-line configuration change that says export this somewhere else. The other side of kind of the same coin is tracing you have to explicitly add, or maybe there are plugins to help you. For example, there's a OpenCensus HTTP plugin. So you just say, trace all of these handlers, and it just works. The other side of that coin, without having to do much manual work, is profiling. And profiling gives you, say, CPU or heap usage of your code by calling this start call. So what's this look like? Again, let's do a demo. You may have guessed already, but let's deploy that buggy version that I talked about earlier. So we look here. We have 1.0 and 1.0.0 buggy. Let's deploy this on Cloud Run. And for this version, I made a few changes. One, or two of them, are I added tracing and I added profiling, which I just talked about. And then I also added 2 other bugs. So my hope is that I can deploy this, throw some traffic at it, just to make sure those bugs get triggered. And then we can go look at the tracing and profiling tools in the Cloud Console to hopefully find those bugs. So we'll stick with US Central 1, same service name. This will deploy. It should take just a couple seconds here. Doing the same thing, assigning traffic to the latest revision, and done. I'll use curl just to make sure this is still working. Whoops, /hello. Go delete all of this extra stuff. Cool. We're still getting hello world. Everything is still working. No obvious bugs, at least from this perspective. That one took a little bit longer. So one option, we could send a few thousand curl requests and we could go home at some time around dinner. Or there's another tool called Hey. And what Hey can do is we can take this, clear Hey, and -z is going to be how long we run for. Oh, again. All right. And Hey was built by a coworker of mine, JBD, and it's written in Go, and it can send a configurable amount of traffic at the URL that you specify. So in this case, we're going to say run for 2 minutes, send a bunch of requests to this endpoint. While that's going, over here, let's open trace. And I'll call out on this overview page, there are reports of the different traces that you get. So you might get a distribution of how long that trace took. You can see latency and request percentiles, and then example traces that correspond to those requests. In this case, let's just look at real-time responses that are coming in. And I'll restrict this to example.com/hello.hello, which was the span that we care about. Zoom in on recent code. And immediately calling out here, we have a bunch of requests at the bottom. Those look fine. Those look like about 0, great. We have another line at about 300 milliseconds. That's probably not what we're looking for a hello world application. So that's something to look into. And then the third group is we have all of these clustered kind of in the middle random latency traces. And so just to say, the x-axis on this is the timeline. And so as you go more left, you get older and older. And then the y-axis is how long it took in milliseconds. And so when we click one of these dots down here, we get this timeline at the bottom, which includes all of our spans. So this request took 0 milliseconds. I would say that's an acceptable amount of time. All of these are taking 0. And then you can see we have this one span of the hello span. And let's look up here at 300 milliseconds. So we have our hello span. And then inside of that, there is a slow span. And this is eating up that entire 300 milliseconds. So looking at the name of this, we have example.com/hello.slow. It's pretty clear where we can look when we take a look at the source code that I deployed in a little bit, where we can look and hopefully find out why this is taking 300 milliseconds. All of these other ones in here, 96 milliseconds, 95. Why? You look here, you have spans. Nothing is there, nothing's really helpful, nothing's showing up. but it's still taking 95 milliseconds. What is there to do about that? So, astute gopher, as you can probably guess, we have profiling. And profiling, the default here is CPU time. You also don't want to double check, so you have hello world and hello world test as your services. Check that you're using the right service or looking at the right service here. I've spent more time than I care to admit looking at the wrong one and wondering why profiling wasn't there. Just take it from my experience. You can specify what version you want to look for. Let's say what time frame you want to look at. And immediately jumping out here is Fibonacci. And you can probably guess what this is doing, but before I get there, this is called a flame graph. And a flame graph is giving you some metric. In this case, it's CPU time, but like I said, it could also be, say, heap allocation, where on the x-axis, you have how much of that metric did this function call take across the profiles that we've received. On the y-axis, you have the stack depth of the functions that were called. So if we start at the top here, we have some standard library things like connection.serve, serve handler, serve HTTP, and so on, until we get to hello, which was the handler that we wrote. And then right underneath this, we're calling Fibonacci. And Fibonacci is a very wide, very deep stack thing, and we'll see what the code is for this in a second. But it's not every time you look at profiling, it's going to be this obvious, but it's just another tool in the box to check of where is the CPU time going? Why is this request taking 100 milliseconds? Look at profiling, very clear. So let's take a look at what that looks like. So let's do cd into buggy. This is all the same code that I wrote before. There's no app.yaml here because since we're just deploying a container image, and not on App Engine, we don't need that app.yaml, so you won't see it right here. All of the other code is the same except for the changes that I made. So let's take a look at what that looks for. We will delete that, not worry about swap. All right, you can see we have extra imports here of OpenCensus.io. And then there's this Stackdriver exporter variable on line 15. And then in an init function, which is run during package initialization for your Go program, I create a new Stackdriver exporter, just like I showed you, register that as the trace exporter. And then on line 24 here, I want to call this out. As you're developing your application, you're adding tracing, you say, yeah, I export my data to Stackdriver, you do it, nothing shows up. That's because by default, there's sampling that goes into all of the traces. You don't necessarily need to sample or send traces for every single request that comes in. So you can sample, say, 1% or 0.5% or 0.1%, depending on the level of traffic that you need and the visibility into all of the requests that you have. When you're debugging, you want maximum visibility. You're not concerned about QPS, just show me the traces, are they working? In that case, you need this line right here that says always sample. Always send that data, don't do any 1% magic or anything. There are a bunch of options that you can look into, but I want to call that one out. Finally, you can see in our handler, we have this hello span that we created. Like I said before, OpenCensus has HTTP plugins that will give you even more information and help you debug your web applications. So I wouldn't do it this way if you're writing it. Look into that OC HTTP package. And then you get to the bugs that I added. So it's a switch that creates a random number that's either 0, 1, or 2. If it's a 0, we're going to call this slow function. If it's a 1, we call Fibonacci. So we'll start by looking at slow. And you can see we have this span that we created, hello.slow right here. And then we call time.sleep for 300 milliseconds. Probably not something you want to do in your production application, but it's immediately obvious where to look and how to fix this. Maybe, I don't know, we want to sleep for 100 milliseconds, or just none. All right, and then we have Fibonacci. And Fibonacci returns the nth Fibonacci number, and it does nothing special. It's just recursive, has no caching, and it's immediately obvious, yes, this is something that we could focus on. We can spend our developer time and engineering effort optimizing this function. Yeah, so I think with that, we started with this cloud function. We added a main.go, a package main, to call that function, deployed that on App Engine, added a Dockerfile to create a container image, and then deployed that on Cloud Run. Then I showed you a few tips of adding tracing and profiling. And so tracing is a little bit higher effort than profiling. Profiling, you have a few lines of code that say, enable this. Tracing, you have to plumb context throughout your entire application. And how many people have done that, or at least tried to? Or you look at context and you're like, all right, I need to pass this through my entire application. How? And I'm going to update how. So that's kind of a slow process. And if you have a very big application with a large team of engineers working on it, one team might not have that as their priority for a quarter when another does. So it's helpful to have those kind of two parts of the same side, or the same coin, to get different visibility. Testing, like I said, tests should just be tests. Your Go code should just be Go code. Hopefully, with the caveat of you have some authentication requirements, depending on where you're deploying and things like that. But the code that you're writing should always look like Go code without extra surprises, just based on where you're deploying it. And with that said, that's all I have for today. Your feedback would be greatly appreciated. You can do that in the app. And if you have any questions, you can either find me on Twitter, or I'll be out in the hall after the talk. Thank you.